All right, good morning. So today we are going to go over lesson 1.2. There is a bunch of new terminology that we're going to go over, which is listed behind me. The major concept of today, we're going to be discussing segments, finding the length of segments, and also talking about a postulate called the segment addition postulate. Okay, but before we get into that, let's go over the vocabulary. So the first term is a postulate. A postulate is a rule that is accepted without proof. So today, as I said, we're going to talk about the segment addition postulate, and that's a rule that we're going to be using for a bunch of geometry problems we're going to be looking at, but we don't need to prove the rule. So it's just a rule that we accept, and then we use it. An axiom has the same definition. An axiom in geometry is a rule that is accepted without proof as well. All right, so coordinate. You guys are familiar with coordinate. You're used to plotting points in our coordinate plane. Okay, so a coordinate, a real number that corresponds to a point on a line. Distance. The distance is the absolute value. Okay, absolute value is always positive, right? So distance always has to be positive. The absolute value of the difference of two coordinates on a line. And I'll show you how to use the distance formula later on. Construction, a geometric drawing that uses a limited set of tools, usually a compass and a straight edge. So a straight edge, an example of a straight edge would be a ruler. Congruent segments, line segments that have the same length. Okay, I'm going to go over some notation in just a bit. Notation in geometry is super important, and here's an example. All right, so here we have segment AB and segment CD. They are both 5 centimeters long. You see the little tick mark on both of them? That's indicating that they are the same length. Okay, now notation, you can either say that segment AB is congruent to segment CD, or you can say AB is equal to CD. When we don't have the bars over top and we're using the equality symbol instead of the congruency symbol, that's indicating the length or the distance because we're talking about the numeral, the number value. So again, it's basically kind of saying the same thing, but the notation is different. Here with congruency, we're talking about the geometric figures, the segments being congruent to one another. And here we're talking about the distances being equal to one another. Okay. Last term, between. When 3 points are collinear, that's a term from our earlier lesson, 1 point is between the other two. So A, B, and C are collinear, meaning they all are on the same line. And then we would say that B is between A and C. Okay. It's not necessarily exactly in the middle, right? It's not the same distance from point A as it is to point C, but it's somewhere in between. Okay, so those are your new vocabulary terms, so make sure you get them down in your notes. Let me erase the board and get us started with some notation information. All right. So as I said, in geometry, the notation is super important. So I'm just going to go through notation again. All right, so we could say AB with a little bar over top of that. That's talking about segment AB. If we have AB with a little line notation over top, that's referring to line AB. All right, if we have AB with a ray over top of it, that's talking about ray AB. Right? And then if we have AB with nothing over top, that's indicating the distance from point A to point B. All right. The reason notation is so super important in geometry is because when you read a problem, the notation is going to be used within the directions or within the problem itself. So you need to be able to read and understand what the problem is asking you to do or what the directions are telling you to do. So in a problem, if it says something about find AB, and they just have the letters here without the bar over top, you need to understand that means find the distance from point A to point B, okay? All right, so let's do a quick example of finding the distance between 2 points. So if I have a number line, all right, and I'll go from -3 to 8. All right. Now, if I plot some points on this number line, so let's say I put point A at -2. We'll put point B at 3. And I'll just put another point C at 7. All right. So if you were asked, what is the coordinate of point A? You would say the coordinate of point A is -2. What is the coordinate of point B? The coordinate is 3. Remember in our definition, in our vocabulary, coordinate, a real number that corresponds to a point on a line. Okay, so the coordinate is the number that corresponds to the point on the line. Now, if you had a problem that just simply said find AB, okay, find the distance from point A to point B. Now, since you have the number line to look at, you can just count, right? You could jump and say it's 1, 2, 3, 4, 5 units away. But I want to do the algebra to show how to find the distance in case you don't have the number line to look at, or in case the 2 points are super far away from each other and you don't want to jump and count, okay? So what you do, the definition of distance, if you go back to your vocabulary, it says the absolute value of the difference, meaning subtraction, of the 2 coordinates. So if you take the coordinate of A and you take the coordinate of B and you find the difference, meaning subtraction, okay, so -2 minus 3, and then the absolute value of that, because distance always has to be positive, okay? So do your math, -2 minus 3, same change. All right, so it's -2 plus -3. That's going to be a -5. And the absolute value of -5 is 5. Okay, so the distance from point A to point B is 5 units. All right. All right, the next thing I'm going to go over is the segment addition postulate. So give me a second to erase. Okay. So segment addition postulate. Remember, a postulate is simply a rule that we accept without proof. Okay, we accept it as true without proof. So the segment addition postulate simply says if B is between A and C, then AB, the distance from A to B, plus BC, the distance from B to C, equals AC, the distance from A to C. All right? So the converse of that is true as well, which we haven't talked about converse, but converse is just flipping the statement around. All right, so I could say, or if AB plus BC is equal to AC, then B is between A and C. All right, so the opposite statement, flipping it around, is true as well. Okay, so let me show you an example. I'm going to use different letters instead of A, B, and C for our example, but the concept is still the same. All right, so if I have a line, and I'll use points D, E, and F. Okay. Now, point E is between D and F. Okay, and this says that if you have a point, they use B, but if you have a point between two other points, then this segment, DE, plus this segment, EF, is equal to the whole segment, DF. Okay, so you could say that DE, the distance from here to here, plus EF, the distance from E to F, is equal to the distance from D to F. Okay, and then I could use numbers to illustrate this even more, right? If I say that this is 2 units long, and this is 5 units long, okay, well, if this is 2 and this segment here is 5 units long, then how long would, or what's the distance from D to F? We should just add them together and get 7. So let's fill in the numbers where they belong and see what happens. DE is 2 units long. The distance from E to F is 5 units long. And if you add them together, you get 7, which makes sense. The distance from D to F is 7 units long. Okay. All right, I think I just have like 2 more example problems that I want to go through. Okay, so you might be given some coordinates, right? You might be given that A is located at -5, 5 in a coordinate plane. B is located at -2, 5. C is located at 2, -4. And D is located at -1, -4. All right, and then you might be asked to determine, is AB, segment AB, congruent to segment CD? Okay, and what we're going to do for this example is we're going to plot the points, look at the segments, count the units, all right, and go from there to answer the question. So you'd want to sketch yourself, or if you have graph paper, instead of sketching, you could use your graph paper. Sketch yourself a coordinate plane and plot each point. Okay, so A is at -5, so you go left 5, positive 5. All right, so here's A. And then B is located at -2, 5. So here's B. C is located at 2, -4. Let's see. And then D is located at -1 this way, left 1, and then -4. So here is, what letter is that? D. Okay. And we're asked to determine, is AB congruent to CD? Again, if you have graph paper, it'd actually be easier because then you have all the grid lines to count, okay? But we'll do our best to kind of use the tick marks below. All right, so count how many units it is from A to B. What is the distance from A to B? You could also use the coordinates like we did and find the absolute difference of the coordinates. In this case, we'd only be concerned about the x-axis, the x-coordinates. All right, but it appears, right, if I kind of drop down and see where A was and see where B was, it looks like it's 1, 2, 3 units long. So this is 3 units long. And do the same thing here. This was at -1, and this was at 2. So 1, 2, 3 units long as well. All right, so since they are both 3 units long, you could answer that yes, segment AB is congruent to segment CD. Okay. Now, if they weren't the same, you would then say they're not congruent by drawing a line through that congruency symbol, just like we do for not equal. Okay? All right, and then the last problem we're going to do today, using our segment addition postulate. So for this example, the directions are just going to say find VW, and then you're going to be given a diagram. This is U, V, W. You're told that the whole thing is 18 units, 18 units long, and this piece is 6. Okay. Now I know you guys could probably look at this and very quickly tell me what the length, the distance from V to W is, okay? But we're going to practice writing out the segment addition postulate because we will be using it when we get into proof, so practicing writing it is going to help you. So the segment addition postulate again says take a small segment such as UV, add to it another segment, VW. Notice that V is between. And it's going to equal the whole segment, UW. Okay. Filling in what you know. Okay, I know that UV is 6 units long. I don't know VW. That's what I'm trying to solve for. And the whole segment is given as 18. Right. So now it just becomes a simple algebra problem where you're going to subtract 6 from both sides to get VW by itself. And when you do that, you have that VW is equal to 12. Okay. All right, so that is it for today's lesson on 1.2. Make sure you take your notes, and I will see you guys for the next lesson. Bye.